Hello, this is Captain Chaudhari. In my series of videos on marine astronomical navigation, today I'm going to talk about azimuth. And I'm going to take the azimuth of a planet today. The name of the planet is Saturn. Right? So the question from my book is: Saturn bore 215 degrees compass. On the PM of 1st December 92, the chronometer that time read 0130. The DR of the ship 34 degrees 50 minutes. 70 degrees east. Ships had 60 degrees gyro and 65 degrees compass. You are required to find out the compass error and gyro error. Now the thing is, why there is a requirement that we should find out compass error every watch. The reason for that is actually the magnetic compass is a very good support, for navigation. You have it on all the ships, right? It is very important to maintain the magnetic compass. So whenever you find that there is large deviation coming, or the deviation not matching the deviation card, you should actually report and get the compass adjusted. Now once the compass is adjusted nicely or appropriately, you will find that the deviation card that is prepared, the deviation card will hold good even if you change the latitude, you change the hemisphere. Because they say that we have two kinds of errors coming in the magnetic compass. One is from the soft ion induction, and other one is from hard ion magnetism. So hard ion magnetism the error because of hard ion magnetism should be corrected actually by the permanent magnets, that is fore and aft and athwart ship magnets. The errors which come in because of soft ion induction should be corrected by soft ion, and we have soft ion correctors as the soft ion spheres and Flinders bar. If the compass is nicely adjusted, the deviation which we get, right, on different headings in different places, it should match the deviation that is given in deviation card. The compass error is calculated to find out the deviation on different headings. Actually, deviation depends on the heading and the ferromagnetic material of the ship, and variation depends on the place. The variation for a place can be removed once we read the variation from the compass rose. It is provided in every chart. So we remove the variation part from the compass error, and the remaining is deviation, and deviation should be as per the deviation chart, right? So that's the reason we find out compass error and we compare the compasses. Now here we are going to find out the azimuth. On an observer's rational horizon diagram, what is azimuth? So let us understand it on this observer's rational horizon diagram. The DR of the ship is 34 degrees 50 minutes north. So I may draw the equinoctial like this. Declination of Saturn is 17 degrees 43.2 south. So the declination of the Saturn is south. LHA is 26 degrees, right? So LHA 26 degrees means we would find the Saturn over here. So this is the direction of the Saturn, and azimuth is the angle that is measured with the celestial meridian, the smaller angle. Right? This is the celestial meridian, this is the inferior meridian. So on the celestial meridian, the smaller angle that is made with the vertical circle, observer's vertical circle passing through the body, this angle is azimuth. So although PZX triangle is over here, but the angle azimuth which is stated for the present position of Saturn would be south something west. Now you can see if the latitude is north, the equinoctial goes to south. So there is a great probability of the body to be seen in the south direction. So normally you would hear that the naming of A, we are talking about ABC table, naming of A is usually opposite to latitude, right? Which means that the naming of A is done generally opposite to the latitude. If the latitude is north, we will name it south, and if the latitude is south, we will name it north. It appears from the behavior of equinoctial, like if the latitude is north, the equinoctial goes to south. Except when the LHA is between this range, this particular meridian means LHA 90, and this particular meridian means LHA of that meridian is 270. When the LHA of the body is in 90 to 70 range, we say that the naming of A will be same as latitude. So this is when LHA is in 90 to 70 range, which means that if the LHA is 0 to 90 or 270 to 360, the naming of A will be opposite to the latitude. Now declination, whatever is the name of declination, B will get the same name. So B is named same as declination. So we will have algebraic kind of sum of A and B. So resultant value, if it is north, that means if north is dominating, then the azimuth will have northerly name, right? And if the LHA is from 0 to 180 range, that means LHA is generally on the west side of the observer's meridian, it will have westerly name. If the LHA is between 180 and 360, then it will have easterly name. So I have told you about the naming of A, B and C. So when we are doing the calculation, please remember we have to carefully name A, B and C. So we'll actually do the calculation and I will show you how the azimuth is named. I will draw this PZX triangle over here for better clarity. This is Z, this is P, this is X. This side is Px, so this is polar distance. This side is co-latitude, so co-latitude, and this side is zenith distance, the 90 minus altitude. So this is zenith distance, this side. This angle is the internal angle Z. Okay, we may say that the azimuth technically is this angle, but this is the internal angle Z, and we need to find this out. You'll appreciate that we know the polar distance because we know the declination. We know the hour angle because we have assumed a certain time to give GHA and longitude, which is applied to the GHA to get the LHA. This is LHA and this is co-latitude, which we decide on the basis of the DR latitude, which means that in a PZX triangle we know these things in continuity. These three things are known in continuity, and whenever three things are known in continuity, direct continuity, we can find out the next fourth thing using the four-part formula. So four-part formula is the solution to find out the azimuth. If we want, we can find out the azimuth using four-part formula. But whenever the tables are given, they use certain sign convention, which I explained to you, how to name A, B and C, north, south, etc. And then we will quickly find out what is the value of azimuth. So first let us decide whether the chronometer, which is 0130, means GMT 130 or GMT 1330. So it means that the GMT is 013000 or 133000. We have a doubt. Which one is correct? So to resolve the ambiguity, we should come down to LMT level, and for that I need to apply LIT. Gives me 4 hours 40 minutes, 0440. Now longitude is east, which means the G is least. For LMT I will need to add, so it becomes 1810, right? And here it becomes 610. But the question says PM, right? In the question, the hint that is given is PM, so this is the correct LMT. So when I decide that this is the correct LMT, I will put the date in question here for the first time. So date in question is the first. On the basis of this date, I will decide what is the date of GMT, right? You can see that from 13, when I move to 15, the date is not changing. It is on the same date. So can I say that GMT is also on the first? So I write here the GMT is 01 day and 13 hours and 30 minutes. This is the GMT. Now this GMT will give me GHA of the body, right? And from this GMT I try to see what is the GHA in the almanac. In the almanac, let's look into the almanac. the GHA for first 13 hours is 309.16.4, 309 degrees 16.4. This is for the first 13 hours. Now let me apply the V correction. Now V is given in the daily page as 2.3. So I will need to see the increment tables. Increment tables will be seen for 30 minutes. I go on 30 minutes increment table. Against V equal to 2.3, I find out V correction as 1.1. So normally V correction is always positive. Now the increment will be seen for so many minutes, so many seconds. So increment which is given for 30 minutes and 00 seconds is 7 degree and 30 minutes. 7 degrees and 30 minutes. So total GHA will be 316 degrees. This is the corrected GHA of Saturn. Now 316 degrees, if GHA is 316 degrees 47.5, I apply longitude to this. Longitude is 70 degrees east. Longitude east, G least, so I will have to add up. So 47.56, 386, which means that the LHA can be written as 26 degrees 47.5. So I will write here LHA 26 degrees 47.5, latitude is 34 degrees 50 minutes north. And one more information I need is the declination of the Saturn. Now the declination of Saturn I find in the almanac is 17 degrees 43.5 south. 17 degrees 43.5 minutes south. That is the declination. The formula for A is tan latitude upon tan LHA. So that is minutes. Gives me 1 point A equal to 1.3781, and because the LHA is 0 to 90 range, so we will say that the A will be named opposite to the latitude. So I say, so the A is south. Now B is tan declination upon sine LHA. So tan declination means tan 17 degrees 43.5 minutes. That gives me 0.7091. 0.7091. It is named same as declination, so I will put south here. Both are south, so naturally I will add them. If they were different names, then I would have subtracted and found the difference, and the naming would be of the bigger one. Now here both are same name, so I will add. It is 2.0872. Now tan azimuth is equal to 1 upon C cos latitude. So 1, this is C, and the naming of C will be south only because both are south, so we add the 2, right? And the C therefore is also south, but there is this formula tan azimuth is equal to 1 upon C cos lat. So by putting in this formula, what I get is the azimuth south 30.27 degrees west. 3 digit, it becomes 210.27 degrees. When we say true azimuth is 210.27 degrees, right? So it can be seen like this, but the compass azimuth was 215 degrees compass. So the error is 4.73 degrees west. Compass west, error west. Now in the question it also says that when gyro and compass headings were seen together, let me see in the question, it was 60 degrees gyro against 65 degrees compass. 60 degrees gyro against 65 degrees compass. Can I say 65 degrees compass would mean with the error 4.73, the true heading is, so the true heading is 60.27, and when I compare with the gyro, I find that the gyro is 0.27 degrees low. So this is how the gyro error also can be found out along with the compass.